All right, let's go ahead and jump back into the final Introduction to Web Dev quiz series. This first question we'll be looking at in this video is, which of these is false about Flexbox? A, align items will only ever be about the vertical axis. B, justify content will only ever be about the main axis. C, the main axis is the opposite direction of the cross axis. Or D, flex direction changes if the cross or main axis is vertical. Correct answer here is A. Yeah, so there's kind of a lot of vocab in these questions. So let's just focus on vertical axis, main axis, cross axis. What do these things all mean? There's a very useful little image here where you'll notice our main axis is horizontal right now, and our cross axis is vertical right now. This is their orientation by default. However, you can switch it if you use something called flex direction. So what that means is that they'll swap places with one another. So what that means is if you did flex direction column, it would switch the two of these axes. So now the main axis is vertical and the cross axis is horizontal. So by default, this value is row, but if you, as I mentioned, you switch it to column, it will switch the two. So what that means is when we see the main axis, we want to kind of connect that with justify content. And when we see the cross axis, we want to connect that to align items. So it's incorrect to say that it will only ever be about the vertical axis because we can swap the two. So if we'd had flex direction column, now align items is moving elements along the horizontal axis instead of the vertical. So that is incorrect. Justify content will only ever be about the main axis. That is correct. Remember, main axis, think justify content. The main axis is the opposite direction of the cross axis. This is true as well. If one is horizontal, the other one must be vertical. And last, flex direction changes if the cross or main axis is vertical. This is correct. This is what I just mentioned. All right, next question. User validation ensures you get the right information from a user. B, should never be necessary for forms. C, can be as simple as adding the required attribute to an input element. Or D, both A and C. Correct answer here is D. Yeah, so hopefully you didn't answer B. User validation should be necessary for your forms. You should assume that your user can and will give you the incorrect information that you want. So you should always set up safeguards. Without user validation, who knows what your user is going to type into those boxes, you know? So it can be as simple as adding just the required attribute to an input element. So here we have an input element and it's type text. And we would just pop this required in there, and what that means is if they try to submit the form, they'll get a little pop-up that's like, please fill this out, it's required. As I said before, if there's a will, there's a way. A user will put invalid info into your form. Assume the user of your website is someone who has no idea how to fill out forms. So you have to show them some guides maybe for what the input should look like. So here I went through the sign up steps for creating an account on Twitter, and this is what I put for my phone number, and luckily they had user validation because they said, okay, well, clearly this is not a valid phone number, please give us a valid phone number. Because imagine if if I was locked out of my account, I needed to reset my password, or I needed to use two-factor authentication, and they tried to send a text or a call to this number, it wouldn't work. And then your user is just frustrated. So even though it can be annoying sometimes to see user validation, it can be annoying to set it up, it ultimately helps out both parties in the end. So yeah, correct answer here is D. All right, next question. Which is false about get/post requests? A, get parameters are in the URL and posts are in the message body. B, get requests can be bookmarked, post requests cannot. C, both requests have restrictions on data length. Or D, get is not secure for sensitive data, but post requests are. The correct answer here is C. Yeah, so let's take these one by one. Here I have a slide that kind of compares what a GET request looks like on the server and client versus what a post request looks like on the server and the client. So for GET requests, you'll notice here we have what are called route or path parameters, where it'll be included in whatever route they're trying to access. So you can't actually get to this endpoint if you didn't fill in these parameters. You can also have what are called query parameters for GET requests. And what that would look like is down here, we're saying the breed is a Scottish fold. That's an example of giving a query parameter to an endpoint. So you'll notice that for GET requests, the parameters are included in the URL. And what this also means is that they're not super secure, right? You wouldn't want to put your username and your password into a URL, right? Every time you logged into, say, facebook.com, that would be horrible because someone could look at your history and be like, oh, your password is hot dog, you should probably change that. Yeah, GET is not good for sensitive data. Post requests, however, are, and let's take a look at why that is. So you'll notice that we get our parameters from the request body. That's fun, that's interesting. And you'll see on the client, we're creating a new form data, and then we're building up the body so that we can pass it in as a parameter. And it's a lot more secure, right? Because notice we're no longer putting our parameters in that URL. It's inside this form data that you won't be able to see in the URL. So for that reason, it is more secure. So this one's true and this one's true. GET requests can be bookmarked, post requests cannot. So this also wraps into the URL parameters as well. So if I just navigated to this website, hopefully it's some sort of API and it returns maybe like a cat fact or something, I could just bookmark this like I would bookmark any sort of website, right? But for a post request, since it uses these form data, this request body, it's not something you can actually bookmark. All right, so just by process of elimination, we know the answer is C, but let's dive a bit into it. So as I've been, hitting the hammer on the nail over and over again, our parameters in GET requests are in the URL. And if you make your URL too long, will get what's called a 414 error, where the URI is too large for the browser. So like if you just kept putting more and more and more and more and more parameters, at some point the browser's gonna be like, are you serious, dude? This is like way too much information for me. I don't want anymore. So it won't even give you a response. On the other hand, post requests, since you just keep building up this this body, there isn't really a limit. For all intents and purposes, there isn't really a limit like there is with GET requests, which makes post requests pretty powerful. So yes, correct answer here is C. All right, next question. What is false about this endpoint? And so we've got sort of some lines of code here. Feel free to read them. A, it will always return text. B, the client needs to pass a route parameter. C, the client can get a 400 error if they don't use it correctly. Or D, it's an endpoint for a GET request. Correct answer here is B. Yeah, so let's go through which ones are correct first. So it will always return text. Yes, I know this. Why do I know this? So right outside of our if else, we have this line of code that sets the type of the response. And since we don't override it anywhere else in our code, that means that we know our response is going to be text. So this one is true. Then on the next line, we're checking for some sort of parameter. A little mini question within this quiz. Is this a route parameter or is this a query parameter? If you said that this is a query parameter, you would be absolutely correct. Yeah, so we're doing rec.query instead of grabbing it from our route. Ding, 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 ding. Looks like B is incorrect, but let's keep looking at C for now. So if we do not pass in a query parameter of a category of a cat fact, so if our URL doesn't look something like category equals, let's say like food or something. If it doesn't look like this, we as a client use the endpoint incorrectly. So what it's going to do is it's going to say status 400, which isn't great, as status 400 means that is a bad request. If the client uses it incorrectly, they can't get that 400 error. That's true. And then lastly, it's an endpoint for a GET request. I know this because of one little word within this endpoint, and that is this GET. Yes, this is true. If this had been POST instead, this would be a POST request. Then we also couldn't use our query parameters. As you remember, we would have to use the form data. But yeah, so correct answer here is B, because it doesn't need to pass a route parameter. It needs to pass in a query parameter. Right, next question. Try catch blocks are useful for A, making sure asynchronous code doesn't error, B, making sure the code tries its best, C, making sure errors are caught and dealt with properly, or D, making sure asynchronous code runs synchronously. Correct answer here is C. Yeah, so while you might hope it was B, making sure it tries its best, we assume that all the time, at least I do. It actually doesn't make sure that it doesn't error, but it does catch any of these errors if they occur. So for example, if we take a look at this first bit of code, we've got some await statements, so this means that this get value is asynchronous, but we're waiting until we actually get the value so that we can put that into the value parameter. These are awful names, don't name your variables as poorly as I am. But let's say somewhere within get value, something threw an error. That's bad, right? So now our value probably is either A, misformed, or B, doesn't exist. But what we're doing is we're saying, all right, well, we got some sort of value, so I mean, we didn't encounter a problem. So now we're passing that in, and then we pass that in one more time, or we pass the results of get another value of value into another method that's also poorly named. And so once we get to the end, we assume that some other value is valid, but that would be incorrect of us to do. So we gotta wrap this around with a try catch. So what the try catch does is, as soon as we get some sort of error here, we go immediately into the catch. Pretty useful, right? So we're not gonna move on to lines 2 and 3 because we got some sort of error and we have to catch it and we have to deal with it. So making sure they're caught and dealt with properly is super helpful, because then you're not passing some sort of value that isn't what you would anticipate it to be to another parameter, or you're not using that further on in your code. However, as soon as we're done with line 3 and we didn't get any errors, what that means is we can continue with the rest of the code. It doesn't mean we go into the catch. All right, next question. Which of the following is true about auto increment? A, every 60 seconds, MySQL adds 1 to whatever value is in that column. B, it's 0 indexed by default. C, when inserting into a table, you don't need that column. Or D, it's actually manual. The correct answer here is C. Yeah, so A would be sort of like a nightmare situation, I would assume. Like if your database just starts adding 1 every 60 seconds, surely something has to be going wrong. So it is not A. It's actually not B either, surprisingly, because most things are 0 indexed in computer science, but auto increment is actually starts at 1. So yeah, don't rely on it being 0 indexed. You can set it to start at whatever you want, but by default, it starts at 1. And no, it's not actually manual. The computer does some things for you sometimes. So yeah, here's this definition. It performs an auto increment feature. So it defaults it to 1. So if we were adding some sort of row, I don't know, like ID, we had name. So it would start that first row out at 1. And then if we wanted to insert another row into this table, we would just do like our insert statement, insert, and then you just have to put in the name, right? As long as we've set this column to auto increment, MySQL is like, okay, I got it from here. Like you don't even need to keep track of the ID. The next time it's just going to be whatever the last ID was added plus 1, so like 2. Let's say I added in Ben. yeah, and like by default, starts at 1, it will increment by 1. If you want to have it start at a different value, you can do it using this this line of code. So yeah, auto increment, very useful. You have to type less code. Everyone loves that. All right, well, that brings us to the conclusion of the final Introduction to Web Dev quiz, and I guess the conclusion of this series as well. So hopefully you had a little bit of fun. Hopefully you learned a little something. Hopefully you got a couple questions right. And yeah, hopefully you have a good rest of your day.